understanding concave is that it's bent in, and convex is sort of like that mirror where it's bent out, sort of.
Yep.
Okay.
Now some people have concave, convex down, and there's absolutely no problem with it. Just the thing that finally clicked for me is that a cave, this is concave because, you know, a cave is something you go into. You got an entrance here and it goes in. So concave.
Got it.
From this side, it's convex. Caves. Convex.
Got it.
However, generally with a mirror, it's mirrored on one side and not both sides. So it's generally a concave mirror or a convex mirror. I guess you could potentially silver it on both sides, so it is concave or convex.
Yeah.
But that's something that presumably would only show up on a test or a quiz and not something in real life. At least not to my knowledge. We still have that the 1 over the focal length is equal to 1 over P plus 1 over Q. It is running?
No, it's not. You want me to?
It was.
Oh, it was. I'm sorry.
Okay.
I'm sorry. I didn't see the little red blinking up there. I was just trying.
Thank you for checking though, I appreciate that. Yesterday at some point during class, the student said there's some messages just popped up, which means that it decided to stop recording. All right, so generally you think about a mirror reflecting, light hits it, it bounces back, and the light is still going to be doing that with almost any mirror, but when I have a convex mirror, we do need to somehow offset that. If I think about the similar pattern that we had before, I have light in parallel to axis, bounces, and I can put through in quotation marks here. And I'm actually going to try to spell it correctly. Bounces through focal point. So for a convex mirror, light that's coming in is going to bounce off and it's going to go through the focal point. Light through focal point bounces, and we'll put back in quotation marks, parallel. And one reason I put through in quotation marks, especially for the first one, is if my focal point is, if I think about a focal point being there in front of the mirror, if it comes in, it's not going to bounce through that because of the way it's curved, that the angle of incidence equals angle of reflection. Assuming I've drawn it even remotely accurately, it would reflect sort of like that. So how do we deal with the focal point of a convex mirror? Well, the focal point actually is not on the silvered side, it's on the back side. And so I'm going to redraw this, hopefully a little bit more symmetric. It should not change your notes unless you drew it as badly as I did. Then if my focal point is here, it doesn't officially go through the focal point, but it bounces back in line with the focal point. So let's say I have my object here. Light. Jumping back. And then light through focal point and bounces back parallel. Actually, I should put through in quotation marks and not the word back. So light that's coming towards this focal point on this side right here will bounce back parallel. These are just basically reverses of one another. Light hitting center. Bounces back, I'm gonna write down normally. And what I mean by that is that if I have light that's coming down through here, hitting the center right there, it should bounce back like that. So the problem is, where exactly is the image? Well, it's a matter of perception. That if your eye is here, it looks like the light's coming from some point over here. If this is bouncing back this way, let's say that I have some sensor right here, so this is like a giant eye. Well, this reflected light here and this reflected right here, if you trace them back, meet up here. This is where the image is. It looks like it's behind the mirror. And you can sort of see that in our giant convex mirror here. Where the image looks like it's on the other side. You're not convinced, Holden?
No, I'm just looking.
Okay.
I do look smaller though. Everyone looks smaller in that mirror.
So we have to do one other thing here. Typically for a mirror, everything that is on the silver side of it is considered positive, but since our focal point really is on the opposite side, remember the focal length here is half the distance of the radius of curvature, and radius of curvature definitely is on the back side of the mirror. My focal length is considered negative number for the convex mirror. Or mirror generally spelled with R's. My object is still positive, it's on the silver side. So let's give this a focal length of negative 10 centimeters. And let's put the object here, let's see if that's 10, so that's roughly 25. So P is 25 centimeters. Where will the image be? Now I've done a crude drawing here, so let's just see how accurate it ends up being. So mathematically I have 1 over, for contrast, let's use blue. Negative 10 is equal to 1 over 25 plus 1 over Q. So negative 1/10 minus 1/25 is equal to 1 over Q. Negative 7/25 is equal to 1 over Q. And so Q is negative 3.57 centimeters. And my drawing is not too far off, actually, as it comes down to it. I have it somewhere around the 5 centimeter mark, but the negative tells me it's on the other side of it. The negative tells me that it's virtual. Magnification is negative Q over P. And so this becomes negative 3.57 over 25. About
143.
Probably without rounding, without rounding, it would be
Oh, there's no.
1, 4, 2, 8, 5, 6, no, 5, 7. Repeated. And it is indeed smaller. Again, I drew it larger than it actually is, but again, it's a crude sketch by hand. All right, questions to hear? I suspect there's something wrong with my car warranty.
I hate how I need a car to,
Say it again?
well, I hate how I know I'm gonna need a car to get to a job.
Oh. I haven't tried the bus system here, I mean, essentially, when I was in Charlotte, I took the bus downtown often.
Cause I live in Kernersville, so, yeah, I don't think a bus would be practical.
All right, so let's see how well we can actually do this instead of the crude drawing I have. I tried this before, but I guess, Thomas, you probably have the best view. Is that this perpendicular to that?
No, not quite. These are go clockwise a little bit.
Clockwise would be,
To the bottom to the left.
No, no,
Yeah, there.
a little more. There you go.
there?
Yeah.
That was better.
All right, so that's my mirror, right there. Setting up, we've got, let's make the focal length there, the 60 mark. So focal length, negative 10 centimeters. We'll put the object at 30 centimeters, so 10, 20, now let's make it 40 centimeters. So P is 40 centimeters. And we'll make the object 15 centimeters tall. Right. Perpendicular?
Yes.
So height of object, 15 centimeters. So light coming to parallel will reflect backwards. This is, even though I've drawn it as a flat mirror here, the fact that I've set a focal length of negative 10 centimeters is indicating that it is a convex mirror. That look parallel?
Hard to tell, your arm.
Do you want someone to help hold it up?
Yeah, just, you know, that
Yeah, I'd say
ish.
ish, yeah.
So light coming in parallel is then going to reflect through or reflect away from the focal point. And then light that bounces off the center this is light coming in parallel. It's gonna bounce off. Light that comes in this way is gonna bounce off down there. And so that should just be 15 centimeters going the other way. That is a point. So light that hits the middle should just bounce straight back. And they meet right here. Let's see how accurate we were. So my prediction is that Q, this is prediction, actually this is experimental. Looks like about 7.1 centimeters. My height,
0.71, that's 7.1.
yeah, 7.1. It should be 7.1 centimeters. My height of about, that's Q, and then height of image, about 3.2 centimeters-ish. Now let's see what we predict. Oh, actually, there's one small mistake here. Q. What's wrong with Q?
It's positive?
Yep, it should be negative. Because I'm claiming that the image is going to be virtual image. The light rays do not actually physically meet there, they just appear to meet there. So 1 over negative 10 equals 1 over 40 plus 1 over Q, negative 1/10 minus 1/40 is equal to 1 over Q. Then we get negative 5/40 is 1 over Q. Therefore Q is equal to negative 8 centimeters. So we're about 12% off. The magnification should be the height of the image over height of the object, which is negative Q over P. And so predicted magnification is 8 over 40, which is 1/5. And in reality, our experimental magnification, so this is M, I guess, theory, and then experimental magnification would be 3.2 over 15, which is a little bit more than 1/5. Like 214.
213 repeating.
213.
Yeah.
And theoretically, it should have been 0.2. So, for physics demonstrations, not too bad. I guess it helps that we weren't actually doing anything physical, just drawing pictures. All right, questions to hear? All right. The textbook gives you a couple other equations that I don't really care for a whole lot. And so on a quiz or test, I will not give them to you, but I just want to at least show you where they come from. we have 1 over F equals 1 over P plus 1 over Q. I have two fractions here. Flash back to whatever grade that was. How do you add fractions?
And the lowest common denominator,
And what's my common denominator here?
PQ.
So I multiply this side by Q over Q and this by P over P. And so I have Q plus P over PQ is equal to 1 over F. In other words, my focal length is PQ divided by Q plus P. And so they give that equation to you instead of, and then similarly, they have 1 over F minus 1 over P is equal to 1 over Q. And they go through a similar process. This becomes P minus F over PF is equal to 1 over Q, or Q is equal to PF over P minus F. And through a very similar logic, P would be QF over Q minus F. I believe you should be able to handle that equation right there. And so this one I'll give to you. I'm not planning to give the other three to you. Have you seen the clamshell mirror floating coin trick?
The what?
Clamshell mirror floating coin illusion, sorry.
I don't think so, that sounds new to me.
Basically, you've got, think of a clamshell, except it's a mirror, it's a shallow mirror here with a shallow mirror on top of it. You put a coin in the bottom of it, and it looks like the coin's floating on top.
Oh, I have, that's why I call.
You have?
Yeah, I have.
Okay. One of you. Others should get out more. So let's analyze that. So I've got a mirror here and a mirror on top of it. There's a hole in the top of the mirror that's sitting on top. And you put a coin down here and the coin appears up here. So it's just the illusion. So when I have multiple mirrors like this, I basically treat it one at a time. So that this will be mirror 1 and mirror 2. That the image of mirror 1 is equal to the object of mirror 2. And the same thing is going to be true if we have a mirror lens combination or multiple lens combination, that the image of the first one is equal to the object of the second one. So let's do mirror 1 first. That's right. I apologize. Mirror 1, mirror 2. So let's give this some height, and we'll call it H. And we can stick in a number if we need to, but I think it's about 10 centimeters. The focal length is also equal to the same thing. So this is sitting at the focal point of the first mirror. Or the bottom is at the focal length. The coin right itself has some height, and just for the sake of a different letter, we'll just call it Y. So let's see where the top of the coin is. So I know that 1 over F equals 1 over P plus 1 over Q. That's basically the equation I'm going to be using for more than one chapter. So 1 over my focal length is equal to, well, I'm thinking about that top of the coin there. So my object is just that height, or the focal length, minus y. So this is 1 over the focal length minus y is equal to 1 over q. And I call it q sub 1 because I can have more than one image. And so 1 over q sub 1 is equal to 1 over f minus 1 over f minus y, which is, getting the common denominator, f minus y minus f over f minus y, which is negative y over f minus y. Make sure I'm still in the right place here. Oh,
Yeah, shouldn't you have multiply that by another f?
is that what you're saying? Yep. Make sure I didn't mess something else up. And I'll keep the negative there. So therefore, Q1, the image from the first mirror of the top of the coin here is going to be the focal length times the focal length minus the size of the coin over the size of the coin. Recognize that the focal length is larger than the coin itself. So f is a positive number because it's the concave mirrors. F minus y is a positive number because y is small compared to the focal length. And so ultimately Q1 is a negative number. Where does that put it? If Q is negative.
On the other side of the mirror.
So that would put it up here,
Yeah.
somewhere up here. So now that is the object for mirror 2. When I was first doing this analysis, what I did it was adjunct at CPCC. I'd gone through it beforehand, I'd done all the math, was presenting it in class and realized partway through my presentation that I'd made a mistake. So I scrapped it and said, well, just try again next time. Worked through it again, got the answer that I wanted, brought it in class, started going through it again, realized I made a different mistake. Said, well, just scrap that, we'll try again next time. Third time I got it. So whenever I'm doing this, I always think, all right, where's my mistake this time? Let's just find out, it's part of the adventure. All right, so this becomes P right here. That's Q1. And so this becomes, I guess, P2 in a sense. That is the object distance for the second mirror. So 1 over the focal length of the second mirror, which should be pretty much the same as the first mirror, equals, well, 1 over this negative, strike that, which is the height here, plus f times f minus y over negative y. It's that distance right there, plus that distance right there, plus 1 over Q2. And, oh, that negative sign should not be there. Because that negative sign was relative to the first mirror, but relative to the second mirror, it's a positive one, so we need the negative of what we got down there. Get a common denominator here. So this becomes Fy plus over y. Fy plus f squared minus Fy plus 1 over Q2 is 1 over F. That's my y over, well, those cancel out, f squared, plus 1 over q2 equals 1 over f.
What, after that plus one over Q2 says equals, what's that? Before you drew your arrow?
This?
Yeah.
That's 1 over f. I just basically moved it over to the outside.
I got you.
Anything else? I know that marker was fading there.
No, it's okay, I just couldn't make out what that.
And so ultimately, I'm trying to solve for Q2, so 1 over Q2 is equal to 1 over f minus y over f squared. So this becomes f minus y over f squared. And so Q2 becomes f squared over f minus y. Now y is some tiny number here. So if as y goes to 0, as y becomes smaller and smaller, this approaches, or doing the math speak, the limit as y goes to 0 of Q2 is equal to just f. So if y is infinitesimally thin, the second image will appear a positive value and basically the focal length apart. That will appear here. Since y is a positive number, a coin does have thickness, my denominator here gets a little bit smaller than just f because I'm subtracting y, which means that the image is going to appear just above something slightly bigger than the focal length, and so it will appear on top, floating right above it. Now at this point, Kong has said he has seen one of these before. The other three of you still never seen it?
I just tried to Google it, and I didn't find an image of it.
You could not find an image?
I typed in clamshell mirror illusion.